previous video, we talked about the difference between and when we multiply probabilities and or when we add probabilities. So let's formalize this a little bit with one new vocabulary and then a statement of the addition rule. So first of all, I want to define the term mutually exclusive. Two events are mutually exclusive. Write this down here. Exclusive. If the two events cannot occur at the same time, or they have no common outcomes. So an example of not being able to occur at the same time was our example of drawing a 10 or a face card. Okay. Actually, I don't like that example as well as another one. Another one would be, so if I drew a card, it can't be both a 10 or a face card. So those can't occur at the same time. Another one would be being a junior or a senior. You can't be both at the same time. You're either a junior or a senior. Two events having no common outcomes. An example of that would be if you roll a die and you want to know about rolling an even number or rolling an odd number. Well, those don't have any common outcomes because an even number would be 2, 4, or 6, and an odd number would be 1, 3, and 5. So you'll notice when they don't have anything in common, we can just add the outcomes because there's no overlap to worry about. So if the two events are mutually exclusive, we're going to look at the right-hand side here, we can say that probability of A or B is equal to the probability of A plus the probability of B. So we have here is A, and we have is B, and we have no overlap. So we just add. Now, let's look at, often though, we do have overlapping sets of outcome, overlapping sample spaces, things that can happen at the same time. So in this case, the addition rule generalizes to this case. The probability of A or B is equal to the probability of A plus the probability of B minus the probability that they both happen at the same time, minus the probability of A and B. I don't think I can fit this on here with that. Minus the probability of A and B. Now, why do we subtract the probability of A and B? Because here we have event A, okay, so event A, and the A is the whole circle. So probability of A equals the whole circle here, the whole circle, whatever is in the whole circle. Then we have B over here, and also B is the whole circle. But right in the middle we have A and B. So if we find the probability of A, that would be all of this blue circle, and the probability of B would be everything in the yellow circle. But then we would have counted the middle part twice. The probability of A and B, we would have counted that group twice. So we have to subtract off the overlap so we don't count it twice. So subtract the overlap so it isn't counted twice. Now, when we did this in the chart with the males and having jobs, or with the 10 of hearts, we could see there was an overlap there, And we could just look at it and figure out not to count it twice. So you don't always have to use the formula to figure this out. The formula is just explaining that we're not counting the overlapping part twice. Okay, so let's look at one more example. ProbStats has 21 students in it. Of these, 17 are seniors and 14 are females. 11 of the seniors are female. What is the probability of randomly selecting one student and getting a student who is a senior or a female? So let's write down all the things we know as probability statements. So let's start out with the fact that our total number of students is 21 and 17 are seniors. So we're just going to say the probability that someone is a senior is 17 out of 21. And 14 are females. So the probability that someone is a female is 14 out of 21. And it says 11 of the seniors are female. That means out of all the seniors, 11 are female. So the probability that you are female, given that you're a senior, is 11 out of what? How many seniors are there? 17. Okay, 11 out of 17. Probably being a female given your senior is 11 out of 17 because you take only the 17 seniors. So what's the probability of being a senior or a female? Okay, so it says 11 of the seniors are female. Okay, now there's one other category that I didn't actually think about here, but we'll get to it in just a second. So let's draw a little picture of what we've got. So if we did a Venn diagram, this Venn diagram, the whole square should contain 21 students. And we're going to put them in two categories, senior or female. So we've got, here's our senior circle. Here's our female circle. Okay, so we have a total of 17 seniors in this circle and a total of 14 females, but it says 11 of the seniors are female. Okay, so 11 of the seniors are female means that this little group right here is 11 because those are seniors and they're females. So we can actually say the probability of being a senior and a female is 11 out of 21. So 11 out of 21 are in both of the categories. Notice that's a little different between being a female given that you're a senior. Now, there are 17 seniors, so the circle has to contain 17 altogether, so the rest of the 17, the 6 that are left over that are seniors who are not female, go in this part of the circle. So this tells me seniors but not female, seniors who are female, and these are females who are not seniors. So we have 14 females, 11 are seniors. That means we have 3 females who are not seniors. Now, have we accounted for all of our 21 students? We have 6 plus 11 are the 17 seniors. There's another 3 females that aren't seniors, so that's 20, but we have 21 students, so there's 1 student here who is not a senior or a female. So this is our male who is a junior, it happens. Now, we can use this then to figure out our probability of senior or female. So the probability of senior or female, we can do it a couple ways. We can just look at the Venn diagram. 6 plus 11 plus 3 would give me all the people who are in all the categories that are either senior or female or both. So this could be 6 plus 11 plus 3 all over 21, or 20 over 21. Another way we could do it is to apply the formula that we learned. So the probability of senior or female equals the probability of senior being a senior plus the probability of being female minus the probability of being senior and female. Now all of these probabilities are non-conditional. In other words, they're out of the whole group. Out of the whole group, 17 out of 21 seniors, 14 out of 21 females. Clearly we couldn't add them together. We'd end up with 31 out of 21, which isn't possible. Minus 11 that are in both groups, and that gives us 20 out of 21. You could also have written this in chart form. And so sometimes some students really like the Venn diagram, drawing that, but some students might prefer the chart method. So in the chart method, we have two different variables, so we're going to make a 4x4 grid here for our chart. And so we're going to put male and female and senior and not senior. In this case, we'll just go ahead and put juniors because there aren't any others but seniors and juniors in this class. And we've got our total here for each of this. So total males. Okay, well, we were given total seniors and total females. So let's start with that. Total females, 14. Total seniors, 17. Total people in the class, 21. Well, that allows us to fill in these other two right here. We know this has to be 7 males who are, 7 males total in the class, and this has to be 4 juniors total in the class. Now, the other piece of information is that 11 of the seniors are female, so we're going to put an 11 here. This would allow me to fill in then this column, knowing that the other 6 seniors are male. It also allows me to fill in this horizontal column, knowing that the other 3 females are juniors, and then that allows me to fill in this column, showing me the 1 junior who is a male. Once you have this information, you can see the or. What's the probability that you're a senior or a female? You would add up the 6 plus the 11 plus the 3, not counting the 11 twice. Okay, so we're only looking at these 3 groups. You're a senior and a female, or you're a female. Okay, so those 3 add up. So this is how you can do the addition probability rule.